Hello, I am Merve. I will talk to you about photon, phonon, and electron interaction with light. Phonon. A phonon is the number of common vibrations of atoms in a crystal lattice. Because it is not physically a particle, they are called rays. It has two types. First, optical phonon. Second, acoustic phonon. Optical phonons have higher energies and are easier to pair with photons. Acoustic phonons, on the other hand, have lower energy. Electron. An electron is a subatomic particle with a minus fundamental electric charge. Because they have no components or non-substructures, they are considered elementary particles. Electrons exhibit both particle and wave properties, so they can collide or diffract with other particles. Because they are charged, there is an electric field surrounding them, and a magnetic field occurs. Electrons absorb energy in the form of photons if they are irradiated or accelerated. Electrons can be transferred between two orbitals by releasing or absorbing photons with the same energy as the potential difference. Photon. Elementary light particles are called photons. The photon does not have any stationary mass, and this allows interactions over long distance. The photon is also the force carrier of the electromagnetic force. Although its mass is zero, it is even affected by gravity. The photon is governed by quantum mechanics and shows wave-particle duality. This indicates that the photon shows both wave and particle properties. Its atomic mass is zero. It travels at the speed of light. It can enter interactions as a particle but propagates as a wave. It also has light wave properties. It can enter interactions as a particle, but it spreads as a wave. The photon has no mass and always moves at the speed of light in a vacuum. Light is the flow of photons. When a photon of light hits an atom, the electron is emitted. This event can be measured using the photomultiplier tube, PMT, a member of the vacuum tube family. How many photons per second are moving in our home or office lighting? Do you know? 10/18. Then, how does the photon interact with matter? A high energy photon in this interaction is the absorption of this photon by the nucleus, gamma ray, is absorbed by the atomic nucleus, and the energy of the photon is absorbed from the nucleus. It allows the particle to jump and become free. This particle is a proton, a neutron, or it could be an alpha particle. In this way, the atom of a high energy gamma ray, we see that it interacts with its core and causes the release of an alpha particle. And photon occur elastic collision. The energy of the incoming photon in this type of the interaction, it is not enough to pluck a particle from the core. While the atom remains the same, the photon changes direction by the scattering. After the wavelength of the approaching beam is scattered set. Compton scattering. Because the electron breaks away from the atom ionized, it's done, so it's changed. And photon-electron inelastic collision. All incoming photons in inelastic collisions, it transfers its energy to the electron and the photon disappears. Two different according to the energy of the incoming photon, the situation may occur. A. The electron bounces off its own orbit with the energy it receives, but it doesn't stay in an orbit, and points back into its own orbit. In this case, the energy it receives, it releases a photon with equal energy, because the photon is first absorbed by the electron and then realizes the collision in an elastic. Photoelectric event. The energy that the photon transfers to the electron is greater than the binding energy of the electron. This indicates the electron breaks off from its orbit and turns into a free electron. Such an inelastic interaction has been called photoelectric event. Because photon energy is electricity, it turns into energy. And finally, photoelectric event. Semi-metal fan ultraviolet light is sent to the surface. Electrons are sent from minus plate to plus plate. They start moving right. In this way, an electron current begins in the wire, which is it also means electric current. The current generated in the wire can be measured by, an ammeter. And thank you for listening to me.